Okay, read over the scenario and then make a prediction for number one. So you could either say player one or player two. So who said player one originally? Yeah. Okay. Because what, the 4 out of 6 chance of getting the 1 through 4? And then who said player two and why?
The odds of rolling 5 or 6 will like overpower the low numbers.
So odds of rolling 5 or 6 is going to be larger more of the time. Okay, so this is what mine looked like whenever I did my simulation. So instead of having a dice, I actually used a simulator. I just Google searched dice simulation, 2 dice, and then I rolled it 20 times. And this is what I got. Anybody get something close?
That's exactly what
That's what y'all got? Okay. In my last class, 2 had tied. 5 people player 1, 3 people player 2 won. So it was a little different. Okay, here is what Miss Dobbs got. And remember with any kind of like calculation, when you're finding on B player 2, you do have to show where the 182 came from. And so I showed that.
That's so
silly. It's silly. All right, and then here is our sample set of all the events that can happen. And so I put a little W by anytime player 1 would win. And that came out to 16 out of the 36, which is 0.44. So that means player 2 would be 1 minus 0.44, which is 0.56. So Ms. Dobbs was actually closer with 0.43. I think it was like 125 or something like that. So her probability was closer. Do y'all remember the law of large numbers that we learned? So the reason her probability was closer to the actual because there was a bigger sample. Yep. Anybody write anything different or want to add to that? More and more, like repetitions, isn't that what I heard earlier? Multiple repetitions of the experiment. All right, so let's look at a probability model.
For your reasoning, could you just write down large numbers?
Yeah.
Just leave it at that?
That's what I did. Why do you think that is, law of large numbers?
Okay. Because they're a large number?
More and more simulations. A large sample size, multiple repetitions, that would be an example. All right, list showing all possible outcomes is called your sample set. And then their probabilities, you also have to include in probability model. To be a valid model, all probabilities have to add up to 1, and each probability is between 0 and 1. Here are the basic probability rules. The complement is the probability of an event not happening. So the way you find that is you take 1 minus P of the event happening, and you get what is not happening, the probability of not happening. Mutually exclusive are events that cannot occur together. So an example of this would be being in Algebra 2 and being in AP Stats. Those can't occur together because you have to take Algebra 2 before you take AP Stats. So that would be a mutually exclusive event. I think some on the Ed Puzzle, do y'all remember any of those examples? For the spades and the red cards. Yeah, spades and red cards, mutually exclusive. Can't happen together. A number card and a face card can't happen together. Like, they're mutually exclusive. So the way you find probability of like probability of A or B, is you take probability A plus probability of B, and then you subtract any that are both. So an example of this would be, let's say A is you're in AP Stats. Let's say B you're in AP Chem. Is anybody in AP Chem? Okay. So I would say probability of A or B, I would count up how many is in AP Stats, how many is AP Chem, and then subtract any double counts. So that's the probability of A and B. But if they're mutually exclusive, like Algebra 2 and AP Stats, I can just add up all my Algebra 2 students, all the AP Stats students, to get how many total there are. Okay, so I want y'all to work on the problems down here. So go ahead and talk to your partner about that. Okay, so looking at the problem about number of children and probability, explain why this is a valid probability model. Anybody want to take that?
All the probabilities.
They all add up to 1.
It's interrupted, buddy. You stole the show.
Okay, so all probabilities
Equal to 1 or between 0.
between 0 and 1. And then they add up or have a sum, add up to 1. Explain why events have one child and have two children are mutually exclusive. What does that mean?
They can't occur together.
They can't occur together. Because if somebody asks you or asks me, do you have one child? I'll be like, no. Then do you have two children? Yes. Like I can't say yes to both. I have two. So cannot happen together or at the same time. It's either one or the other. Something like that. All right, so for each of the following, write the event using proper notation and find the probability from the table above. Find the probability that a randomly selected mother has less than 2 children. So probability of X, uppercase X, has less than 2. This is how you write it in proper notation. So it's an uppercase X. And what did y'all get for that? 0.22. It was just straight from the table. Find the probability that a randomly selected mother has 1 or 2. So probability that X equals 1 or X equals 2. Did you write it this way? Fix it. This would be proper notation.
Oh my god.
The correct notation. All right, what do we add to get to this?
0.22 and 0.41.
0.22 plus 0.41 is...
Right here, using proper.
6.3.
Yep.
Will we have this formula like for the
Can you talk to us on it?
So there will be formulas that you will get.
Is it one of them? Probably.
I know on the Ed Puzzle I talk about it a lot. I don't know if it was yesterday's or if it's the future ones.
I forgot to.
Okay. Find the probability that a randomly selected mother does not have 4 or more. So probability that X is not 4 plus. We could write it like that. No, because we need to write in the notation that they gave us. You could also do it like this. A complement. But you do have to say what A is. A is X equals 4. If you do it this way, you know how in our notes up top it said that? So then how would we find this value?
Just subtract 0.13 from 100. Or
Yeah.
1.
And what do we end up getting?
0.87.
Yeah. Whoa, whoa, whoa. 0.87. Okay. Could you just add up 3? Did anybody do that? You did that perfectly fine. So either way, just as long as you show it. So 0.87. All right, that is it.